we will find the inverse of the matrix function. The matrix function is still a matrix. The inverse is found similar way to just a matrix of numbers. In this case, we have a 2 by 2. So for a 2 by 2 matrix, let's say in this form, it's going to be 1 over AD minus BC. AD minus BC is the determinant. And then A and D, for this 2 and 3, we'll swap place. So D goes there, and A goes there. D and A. And the other two will negate. They will stay in the same position. So negative B and negative C. So that is the inverse of a 2 by 2. Just one thing though. If AD minus BC equal to 0, then A inverse does not exist. And AD minus BC is the determinant. So pretty much we multiply this direction and subtract the other direction. Right. Now similarly to this problem, first we find the determinant e to the t times 7 e to the 3t minus e to the t times e to the 3t. So we have 7 e to the 4t 7 e to the 4t minus e to the 4t is 6 e to the 4t. Alright, so now the inverse of t will be 1 over 6 e to the 4t. We swap places of these two. So 7 e to the 3t and e to the t. And the other two will negate it. So e to the 3t, e to the t. They stay in the same position, but will with the negative sign. And then if we bring the 1 over 6 e to the 4t inside, we should have 7 over 6 e to the 3t over e to the 4t. Dividing, we subtract the exponent, so that becomes 3t minus 4t is negative t, so e to the negative t. And next we have negative 1 over 6 e to the negative t, and then negative 1 over 6 e to the 4t minus t e to the 4t over e to the t is e to the, the other way around. E to the t over e to the 4t is e to the negative 3t. And 1 over 6 e to the negative 3t. And also, just like the wrong skin like we did earlier, this function, the graph would look like this. And so unless t is approaching to infinity, that goes to 0. So pretty much the determinant in this case, 6e to the 4t, is greater than 0 for every t, unless it is equal to negative infinity. So that's why this one always have an inverse.